In the circuit given below, what will be the potential difference between point B and D? So the circuit is connected for resistors with a 6 volt potential differences from the source or 6 volt battery. Then these two resistors are in series with each other, and these two are also in series with each other, and these two and these two are in parallel with each other. So to find the potential difference between B and D, first of all we have to find the current through B and through point D. Since the current passing through point B is also the same current passing through 6 ohm and 12 ohm resistor, and also the current passing through D is equal to the current passing through this 6 ohm resistor and 12 ohm resistor. So if we add these two resistors in series, 6 plus 12, that means this is simply the sum. 6 plus 12 become 18, and this is 18 ohm. The circuit become this one because these two combined and gives me as a one resistors. So then this 12 plus 6 is also added seriously together and become 18 ohm resistor. And also these two resistors are in parallel with each other, and when we add the parallel resistor with each other, R become R1 over R is equals to 1 over 18 ohm plus 1 over 18 ohm, which is equals to 2 over 18 ohm. This is 2 over 18 ohm. And finally I get that the resistance, total resistance R in the circuit is 18 ohm over 2, which is directly equal to 9 ohm. So this is the 9 ohm. I get the total resistances or the equivalent resistance into the circuit. I have the net volt from the source. Then I can find the total current is passing through the circuit. So from this, just I can get that the total current in the circuit is equals to the total potential differences divided by the total resistances. So total potential difference is 6 volt divided by total resistance is 9 ohm, which is directly gives me 2 over 3 ampere. But after I get the total current is the current passing through the circuit, and at this point is or at junction A, this current is divided into two parts. That means the current passing through point B and the current passing through point D. That means the total current from the source is divided into two parts. This is current I1 and this is current I2, I can say. But the sum of I1 and I2s are equal to the total current. That is from the Kirchhoff's junction rule. So I can say that I1 plus I2 is equals to simply the total I. So this is the Kirchhoff junction rule. The current is separate or divided at a junction and then come together as a once again. When we come to point C, current 1 comes to this side and current 2 come to point C, and they also add it together and gives me the total current. That is why I1 plus I2 is equals to the total current through the circuit. Then I can get the current passing through B, that is current 1, or I1 is the current passing through point B and I2 is the current passing through point D. So then finally we can get that the current I1 is equals to, I1 means the current passing through these resistors. This is 18 ohm. I1 is equals to V divided by the R of this R series 1, or I can say RS1, which is total voltage is 6 volt divided by 18 ohm. This is directly equal to 1 over 3 ampere, and the current passing through point C or I2 is also V over the R in series 2, which is 6 volt divided by 18 ohm. This is 1 over 3 ampere. So just we can see that I1 plus I2, which is equals to the total current I, but the total current I is already we have get it is 2 over 3 ampere, but I1 is 1 over 3 ampere plus I2 is also 1 over 3 ampere. Then if we add these two numbers, we get 2 over 3. To find the potential difference between B and D, just I have to find the voltage across these, or the voltage between point A and B and the voltage between point A and D. Our circuit is like this. current I1 is passing through this point B and current I2 is passing through point D, and then we can find the voltage between point A and B. That means the voltage across point A and B, voltage AB, is equals to the current passing through this line, that is line AB, I1 times the resistance between the points A and B, that is 6 ohm. So 6 ohm, which is equals to I1 is 1/3 ampere times 6 ohm is equals to, simply it is 2 volts. So the voltage between point A and B, or the voltage across this resistor 6 ohm, is directly it is 2 voltage, and the voltage across point AD, A up to D, is given by the voltage across AD is the current I2 times the 12 ohm resistor, it is 12 ohm resistor, which is equals to I2 is 1/3 ampere we have calculated, and this is 12 ohm directly, which is equals to 12 divided by 3 is 4 volts. So the voltage across AD is 4 volt and the voltage across AB is also 2 volt. Then the difference in voltage between these 2 points is given by the potential difference between B and D is the difference of potential, electric potential between AD, that is VAD minus VAB, that is the voltage across point A and B. So this is equals to the voltage across AD is 4 volt minus the voltage across AB is 2 volts. So this is directly equal to 2 volts. So the correct answer is on alternative B. But we can do this question in another way. That means you can find the voltage between B and C. That means this is directly given by the current through B and C is 1/3 ampere. So 1/3 times 12 is, we get the 4 volts, and the current through DC is also I2 times 6 ohm resistor, that is 1/3 times 6 is 2 volts. So when we subtract the 4 and the 2, exactly you will get the same answer. So the potential difference between point B and D is 2 volt directly. Okay, we can solve this question also by using the Kirchhoff's rules, that is the junction and the loop rule. From the junction rule at junction A, the current I from the sources, or the total current passing through the circuit, so this is 6 volt, is separated or divided into 2 parts, I1 and I2. So exactly we can see that the total current is separated into 2 parts. I is I1 plus I2. This is the Kirchhoff junction rule, I can say, as question 1. And the second one is we can use the 2 loops from this circuit. The first loop is the line which is passing through A, B and C, and again the circuit continues like this. And the second loop is the line which passes through A, D and C. That means this line, the lower one. So then according to the Kirchhoff's law, the EMF in the circuit is equal to the sum of all the potential difference drop across that circuit. That means the potential differences drop across the 6 ohm and 12 ohm resistors added and gives me the 6 volt. So that means that I1 times 6 ohm plus I1 times the 12 ohm is equals to 6 volts. So this is the source of EMF in the line or in this loop, and we have 2 resistance, so we have a 2 potential difference which is dropping on these 2 resistors. So this means that I1 I take as a common end 6 ohm plus 12 ohm, which is equals to 6 volt. So this become 18 since the resistors are simply in series. So can say that I1 times 18 ohm is equals to 6 volt. Then from this I can find directly I1 is equals to 6 volt divided by 18 ohm, or which is directly equal to 1/3 ampere. Just the same answer we have got earlier. And also the current passing through the lower resistors are, if I take this loop become I2 times 12 ohm plus I2 times 6 ohm resistor is directly equal to 6 volts. So this is also included in the lower lines. So then directly we can write that this is I2 take as a common 12 ohm plus 6 ohm, which is 6 volts. This become 18. So I2 times 18 ohm is equals to 6 volts. Then I2 become, it is 6 volt divided by 18 ohm, directly 1 over 3 ampere. So the current passing through the lower and the upper passes, or the current passing through B and D are the same. Then I can find the voltages between the points or across A and B, just like by saying voltage AB is equals to I1 times 6 ohm resistor as before. This is 1 over 3 ampere times 6 ohm, exactly 2 voltage. And also the voltage across the AD, voltage across AD is also given by as 1 over 3 ampere times the 12 ohm, which is equals to 4 voltage, and the difference of them is 4 volts minus 2 volt, which is 2 volt, exactly as we have calculated earlier. Suppose that a voltage source produces 240 volts for a moment. By what percentage does the power output of 220 light bulb will increase? So we are asked to calculate the power increase or percentage power increase when the sources of 220 volts momentarily increases its voltage by 20, that is from 220 to 240 volts. Then when the voltage is increased from 220 volt to 240 volts, then what is the power increase? Power increment is from these sources. So to do this question, first we have to find the power formula. We know that the electric power is given by voltage times electric current, but we don't have the current concept is here. We have only the voltage and the resistance. Resistance of the bulb is simply can take as R. So how can we relate? Then from the Ohm's law, I can omit the I, which is equals to, this is V square over R, or this is also equal to I square times R. I can write like this, but we don't have the concept of current is here. I use this right equation here. The power is the potential difference square divided by the resistance. So then the first power, or I can say P1 is equals to V1 square divided by R. R is simply the total resistance of the bulb. It's not changing. So power 2, or the second power, is the second potential difference square divided by the total resistance R. So then I can find that the percentage increment of the power is equals to power 2 minus the power 1 divided by power 1 times 100%. Exactly, this is the percentage increment. So then if I substitute the value, simply P2 is V2 square divided by R, or exactly this is equals to 240 volt square divided by R, and P1 means that V1 square over R is directly given by, so this is 220 volt square divided by R. So if we substitute the value, this is 240 volt the whole square divided by R minus 200 is minus 220 volt the whole square divided by R, the whole divided by P1 is 220 volt the whole square divided by R times 100%. So if you do this calculation, you can take V square over R outside and cancel. Then what is left is simply it is 240 square minus 220 square divided by 220 square times 100%. So if you do this calculation directly, you get that it is 19%. Exactly, it comes 19%. You can do this math exactly, and the correct answer is on alternative B, which is 19%. Okay, we have 6 resistors, resistor B, C, D, E, N, F, and G, and we have a potential difference here, but it is unknown. Then the current passing through the resistor B is, the current passing through resistor B, let me call this is I1. Current passing through this resistor is I1 is equals to 4 ampere. Then what is the amount of current which is passing through resistor G? So let me call this is I3. It is unknown. But to find that, we have to know the current passing through resistor D and E also. Let me call this is I2, but this is the source of the potential differences or the voltage from the source. So the total current from the source is divided at this point. Let me call this is junction A, and this is called, let's call this is junction small b. But at this junction, the current I is separated into two parties. One is I2 passing through resistor D and E, and the second one is the current passing through resistor B and C, which is I1. So from the junction rule directly we can see that I1 plus I2 is simply, let me call, the total current is I. So at this point also we can see this is current I1 and this is the current I2. This is current I2, and they add it together and become the total current is I passing through the line here. So current I is the current passing through resistor F and resistor G, or which I call it I3, or simply let us call it, it is simply I or I3. I can use like that. So it is so simple to use. I1 plus I2 is simply I, and I is, let me use simply I is the current passing through resistor G. So I have to find this current. Since I1 is given, I1 is 4 ampere, it is simply known. So then 4 ampere plus I2 is simply I. Then I have to find the current I2 which is passing through the resistors D and E. So to find this, I have to find the Kirchhoff loop rules. So I have here 3 loops. One loop is the line which includes resistor F, G, B and C, this loop, and the second one is the loop which includes the resistor D, E, F and G, and sorry, it is these loops. So then from these two loops, or also I have the third option which is the loop which is including B, C, E and D. But the simplest way I can use is, if the resistor, I take this loop, that means the loop which includes resistor B, C, E and D. So the current I1 and the resistor RB plus the current I1 resistor RC minus, I take this is a minus because I'm moving against the current. If I take this loop, I'm moving against the current because I assumed initially the currents are moving in this direction. So if I move against the current, I take this negative I2 resistor E and again minus I2 resistor RD. So then exactly I can get that this is I1 RB plus RC minus I2 RE plus RD, which is equals to 0 because there is no source of EMF in these circuits or along this loop. Source of EMF is not included. B, C, E, D. This line has no, or this loop has not the battery or the source of EMF. So I make it equal to 0. Since since RB and RD, RE and RC all are equal, so they are simply R, or simply this is I1. RB and RC are equal, simply R. So I can take twice of R minus I2 into RE and RD are also equal, they are simply R. So I take twice of R, which is equals to 0. So if I transfer this to that side, is I1 twice of R is equals to I2 twice of R. So 2R cancel each other and I get finally current I1 is equal to current I2. So this means that the current passing through resistor B and C is equal to the current passing through resistor D and E, and these currents are added together and gives me the I, or simply the total current is through F and G. So since I1 and I2 are equal and I1 is given, it is 4 ampere, but from the junction rule just we have said that I1 plus I2 is equals to simply the total current is I. So I is equals to, which is I1 plus I2. I1 is 4 ampere plus I2 is also, we have calculated, is equal to I1 4 ampere, and the current passing through resistor G is 8 ampere. So exactly it's 8 ampere, and the correct answer is on alternative B. A small radio receiver uses a battery that delivers a constant current of 25 milliampere, or which is 2.5 times 10 raised to minus 2 ampere for 3 hours. 3 hours means simply it is 10,800 seconds. Then calculate the total charge delivered by the battery. So we know that the total charge is given by, then from the definition of the current is, the total current is equals to simply charge delivered per time, or charge is equals to the amount amount of current flowing times the time it takes. So this is 2.5 times 10 raised to minus 2 ampere times 10,800 seconds. So this is equals to, if you multiply these two numbers directly, you can get it is 270 coulombs. The correct answer is on alternative D. So a copper cable has a cross-sectional area of 1 centimeter square. 1 centimeter square means simply 1 times 10 raised to minus 4 meter square, and it has a length of 2 kilometer, which is 2000 meter, or 2 times 10 raised to 3 meter. And the resistivity of the copper is 2 times 10 raised to minus 8 ohm meter. And then what is the resistances of this copper cable? So the resistance of the copper cable is directly, which is equals to the permittivity, the resistivity of the copper times the length of the copper divided by the cross-sectional area of the copper. And if we substitute the values, simply this is 2 times 10 raised to minus 8 ohm meter times 2 times 10 raised to 3 meter, which is length, and 1 times 10 raised to minus 4 meter square. So this meter times meter is meter square, and it cancel with the meter square, only ohm is left. And if you multiply this number, this is 2 times 2, this number become 2 times 2 divided by 1 times 10 raised to, we add this power, minus 8 plus 3, and minus 4 transfer to upward, it become plus 4, and this become 2 times 2 divided by 1 is 4 times 10 raised to minus 8 plus 3 plus 4 is minus 1 ohm, simply ohm is left, or this is equals to 0.4 ohm. So the correct answer is on alternative D, which is 0.4 ohm.